Hello everybody, welcome back to Sequences and Series. So we are dealing with sum to infinity. Now with sum to infinity, here is something that we need to understand. The amount of terms that we have in a series is an infinite number of terms we have in a series. Literally, like we can't get an ending, but there is some understanding that we need to understand. Okay? I'm using words for words in this entire explanation. It's not even an explanation, I'm just like introducing, obviously. So this is where I'm going to introduce you to something called diverging series. A diverging series is essentially when we have a value that gets bigger and bigger and bigger, right? Such that the answer would be positive infinity. So first things first, to get from a diverging series, the answer or the series, right? I'll rather say the series evaluates to either plus or minus infinity. Okay? So either positive infinity or negative infinity. But converging series is when the series evaluates to a finite value. Meaning it actually evaluates to a value which we are able to like physically see, which we are physically able to go to, such as 1, such as 500, such as 10 billion. But infinity is endless. We can never reach a point at infinity, but we can reach finite values. And that is what it means by converging. So what are the conditions for converging? So the conditions of converging is when r is between -1 and 1 for our equation that we are going to go over. And the diverging series is essentially when r is going to be less than, so when r is less than -1 or when r is greater than 1. So notice that in this case here, r is between -1 and 1. So notice it's actually always going to be like fraction values, right? Or equal to 0. And then this one is just going to be values that are greater than 1 and values that are smaller than -1. And then notice that it will go to infinity. Okay. And then notice that, just take note by the way, that r is never equal to plus or minus 1, because in that case the denominator will be 0. And let's go into the equation that we need to know. The equation that we need to know for sum to infinity goes as follows. So the sum to infinity equation is going to be s sub infinity is just going to be equal to a over 1 minus r. Okay, so that's essentially what we are going to have in this case over here. And if this r was ever to be -1 or 1, then therefore we would notice that it's going to be 0 as an output. Okay, let's just avoid the -1 part. I know we can get like 2 if it was -1, but I think there was like a different formula, something like that. It's not 100% sure on that, but just know that this is the formula. Okay, so let's actually apply this into an example. So I don't know if you could tell, but by the fact that we have r in the equation is the fact that we are using geometric series. Okay, so in this case here, we are told to evaluate 5 over 10 plus 5 over 100 plus 5 over 1,000. Do you notice how the value is getting smaller and smaller and smaller over time? And do you agree with me that clearly by inspection, this would converge? since we're adding by numbers that get smaller and smaller instead of bigger and bigger, right? Then therefore that would mean that we're just going to get to a point where we might actually add by 0 if we add an infinite amount of times, because you're getting to a number that's so close to 0 that it's literally 0. That is very intuitive, eh? So how are we going to, so what is our formula again? It's S infinity equals to A over 1 minus R. So we need to find A and we need to find R. How do we find R? We essentially just let the term over here and we divide it by the other term. So R is just going to be equal to term 2 over term 1, where we have term 1 here and term 2 for the next one and term 3 over here. Okay? So we are essentially saying that R is going to be equal to what? 5 over 100 all divided by 5 over 1,000. 5 over 10. Okay? And then from here, we can just tip in times. It's going to be 5 over 100 multiplied by 10 over 5. Where the 5's cancel and the 0's cancel, therefore we're left with 1 over 10. So R is just equal to 1 over 10. So we have R, and we know A is the first term, which is 5 over 10. So therefore this implies to us that the sum to infinity is equal to 5 over 10 divided by 1 minus 1 over 10. And notice we can evaluate this without a calculator, but because I'm lazy, I'm going to use a calculator. So we're going to have in the numerator 5 over 10 all divided by 1 minus 1 over 10. And the answer is going to be 5 over 9. Okay. Not difficult, eh? It's basically doing geometric series, but with a new formula. And obviously, we didn't really properly understand this problem. What do you notice about R? R, in this case, is 1 over 10. And 1 over 10 is the same as 0.1. So doesn't that imply to us that R actually lies between -1 and 1? Right? Because 0.1 actually lies within that interval. So therefore, because it lies within that interval, it actually converges. If R was like 3, for example, or 2, then therefore, what that would imply is that it would diverge. It would be out of the boundary of convergence. Let's do another example, and then we'll get the hang of this. Alright, so here's a question, and this will be the last question for sum to infinity. The example number 2 says, evaluate the sum from x equals 1 until infinity of 2 to the power of 1 minus x, and state if it converges or diverges. So I just put that last part in because you clearly need to state it. It makes sense. And they're probably going to ask that in the exam. Does it diverge or does it converge, and why? So basically, in order to answer this question, we are doing it from 1 until infinity. So do we know what the last value is? No, because we can't get to infinity. So we are going to do exactly what we had in the last question. We are going to use the first 3 terms. Okay, so let's first evaluate the first 3 terms. So term 1 is just going to be where we plug in x equals 1. So 2 raised to the power of 1 minus 1. Okay, and that's just going to be 1 because it's 2 to the power of 0, which is 1. Term 2 is going to be 2 to the power of 1 minus 2, which is just 2 to the power of what? -1, which is 1 over 2. Term 3 is going to be 2 to the power of 1 minus 3. And 1 minus 3 is just going to be -2. And this is 1 over 2 to the power of 2, which is equal to 1 over 4. Okay, so therefore this implies to us that we are going to have 1 plus a half plus 1 over 4 plus ... Okay, so that is our series that we're working with. And it comes from something that's geometric, right? So let's actually just try and determine what the value of R is. in this case over here. But before we do that, let's write down the formula that we're going to use. We're going to use S infinity is equal to A divided by 1 minus R, where we need to know that A is just going to be equal to what? A is equal to 1. And R is equal to what? Well, we need to determine that. So R is equal to what? Term 2 over term 1, which is obviously going to be a half divided by 1, which is equal to a half. And what do you notice? Right? What do you notice? Okay, let's actually just verify this also with term 3 over term 2, just so we know what we're talking about here. So you can say or this one, right? So it'll be 1 over 4 divided by 1 over 2, which is the same as tipping and timesing, which is 1 over 4 times 2 over 1, and that's just going to be equal to a half. So clearly, R is going to be the same as 0.5. And what does this tell us? We'll get to that later. But R is equal to a half, okay? So it's 1 minus a half. And if we evaluate that, that's 1 over 1 minus a half, which is also a half. Tipping and timesing it makes it 2. So therefore, the sum to infinity is 2. And because it converges, there's two ways you can prove this. So the way one is to say, since S infinity is finite, so basically 2, right? It has a value. Then the series converges. Or you could do the second one. Since our R value, right? Since R equals to 0.5, implying to us that R is between -1 and 1, the series converges. You'll mostly get questions where the series converges, but sometimes you'll also get divergence when you have infinity. But for now, just understand this and its applications, and that is it for sum to infinity.